This presentation is based on QML2. So you'll actually see this is us attempting to actually run full screen. So I have two trusty assistants who told me if that goes pear-shaped, but I'll rely on it in the meantime. Hi, my name is Carr. My presentation is on multi-screen development with QtQuick. A little bit of background about myself. I started at Trolltech in Oslo in 2006 as a support engineer. I then migrated to New York, where I worked as a commercial customer, before heading over to the Bay Area, where I actually started operating as a professional services engineer. So basically, I graduated from university and have been rolling around in Qt land ever since, which makes me something of a one-trick pony, but a happy pony nonetheless. A PSO engineer basically means that I get involved in strategic consultancy jobs. We actually collaborate with various partners, chipset companies, and other high-profile businesses in actually Qt usage and trying to get Qt running on devices and shipping products based on Qt. We don't actually have to push too hard, especially in certain domains like IVI and set-top boxes, where we are very well established. I'm telling you this just to give you guys insight into the fact that there is a very big Qt web, which isn't overly apparent. You're almost certainly using devices or flying in planes that are using QML. It's probably being used all around you. Qt technologies and QML now in particular. Our roles basically as the PSO organization are there to facilitate communication, to actually inform potential customers, to actually demonstrate Qt's capabilities, and to foster certain relationships. Cool, that said, okay. And any of you who have actually seen the Raspberry Pi demo downstairs, my lasting legacy on this earth is the actual funny accent that accompanies the videos on the YouTube site. Cool. Our agenda for today is to actually do a case study of the actual Qt Media Hub, and in particular QtQuick. It's a bit of a multi-pronged thing because although the demo is titled, or the presentation is titled multi-screen development, a big point of it is just to show the applicability of QML in domains. We don't normally push it. Nokia has been very good at pushing it as a primary development means for its phones. How many people here develop for Nokia phones? And how many are like pre-existing Qt customers from the days of yore? And how many people here are shipping products based on Qt? Good, okay, so I certainly have my target audience. Cool. Okay, and also this agenda. So yeah, I'd rather delay all questioning to the end of the session, and I'll poll you guys as I go along to try to see what is relevant and what actually appeals to you most. So yeah, I've established the actual basic makeup, but QML usage. How many people here actually have used QML for like more than 3 months? Would consider yourselves to be baseline? And how many of you are skeptical of QML? Thank you for your honesty. Cool, okay, yeah. So like myself and 2 other engineers seated at the front here are responsible for quite a large QML project. We didn't know QML at the start of it. We can't really tell people to use it and vouch for it unless we actually get burnt by the issues, eat our own dog food, you all know the drill. So we actually took something that looked pretty appealing and pretty much geared towards our niche market. As I mentioned, set-top box users tend to like us a hell of a lot. Netflix isn't overly relevant in Europe. In the US, it's quite a big deal, and they actually have a reference implementation of their UI, which is based on Qt. It uses Qt WebKit, but that has garnered a lot of attention towards Qt in this domain, and we're trying to actually basically show them the merits of QML in that space. So this code actually exists. It's currently targeting desktop machines, set-top boxes, and mobile devices. And we test it relatively often. We test it the whole time on different Linux variants. We're all working on Linux. I'm the only guy testing it on Mac. But anyone with these machines should be able to check it out and build it. So the code is available at this site over here. So yeah, I'm not sure whether to keep the URL on screen or not. You can always come up and get it afterwards. This presentation is online. It's on Gitorious as well. In fact, you have my entire revision history, so you can see everything I deleted, which is actually something wholly novel. Cool. Okay, and it's BSD licensed, so if there's any code of any use to anyone, feel free to scavenge whatever you can. Just to give you a rough overview of the way the project is actually established, we basically have broken it up into apps, the actual core application itself, which is C++, and then the individual skins. The QML components are the apps, so that's the way we've actually handled third-party apps, is just by having them, forcing them to be QML applications, and then actually loading them inside of our actual standard QML runtime. And then the actual skins themselves. Again, I'm going to go into depth on how the skins are structured, where we actually implement different functionality, why we did it that way, the way we'd actually recommend doing things. Also, if I am speaking too quickly or too accentedly, please let me know, and I can switch between accents and switch between speeds. So. In the actual core C++ runtime, we do all the things you kind of expect, basically. We do things like widget setup, actually creating the actual QtQuick view, setting a GL viewport on it, things that hopefully to all of you are very familiar, but many people get tripped up by this. In fact, many partners of ours get tripped up by it because of the fact that due to binary compatibility concerns and other things we had to worry about, Qt basically does not follow an optimal path out the box until you actually set various flags or various attributes on widgets and actually set a GL widget on a viewport. You really need to kind of know your way through the straits in order to actually get optimal performance. So part of the purpose of this code being available is for people to see how we actually initialize things, set things up, actually, and it can make a substantial difference to the way things perform. We do things like the actual plugin handling, so clearly we actually need C++ functionality. We play back MP3 files, we actually need to get tag information, so we need things like libtag to be supported. So all of this is actually handled in the actual core functionality, as well as skin discovery, trying to actually troll your machine. Any file level access to your disk clearly needs to be done from C++ as well. So all of that resides in the actual core application. Database handling, populating our database and querying it back, and event filtering. We want this UI to be actually driven via remote control. QML actually has some hard-coded key handling, but at the end of the day, if you want to actually use a random input method, you have to be fairly clever and do some pretty complex stuff just to actually intercept events before they get received and actually squirt out the events that you want. We also have various servers that actually reside in the code. We have like a JSON RPC server, so we can actually do remote control stuff. And we have an HTTP server, which actually is actually meant to share the media that we actually have on our local machine, and also push out QML files to a listening remote control. So you could actually have context-specific QML content on a remote control that's controlling the actual device. And all the model management is clearly done in C++. As I mentioned, things like tag reading. Any custom media type that you want to actually register as being a legitimate media type has a parser associated with it that will actually strip information from those files. And yeah, the best example is libtag for MP3 information. So all of this clearly would exist in C++ land. So this presentation could take two forms. Rather than actually going through exactly how we did these individual things, I mean, the very fact that we're actually doing them in C++ and actually showing you how we actually compartmentalize our development, the hope is that you would actually check out our code and see how we're doing it and raise questions. We are on Freenode on like Qt Media Hub channel. It's going to be on a slide in the future, but this is intended to actually hopefully strike a chord on one point, and then get you to look at the code, and then come back to us and give us feedback or ask us questions. So this is not like a single isolated session. And then the actual skin is just entirely responsible for the UI. And that's a bit disingenuous because we do things like lazy loading in the skin itself as well. So there is some logic in the skin, but by and large, we actually managed to adhere to all data in the actual C++ backend and just UI, like using QML purely for the UI work. Although, yeah, as we'll see, there is some logic required. The beauty of actually using QML in this case is that the only constraints you have when you're writing a skin is that we advertise a certain model structure from the actual C++ backend, and then the actual limitations of the QML language itself. So the actual original Xbox Media Center client that I actually showed over there has a fixed XML layouting scheme, whereby all the functionality is done in C++, and all the functionality assumes that there is going to be a corresponding XML functionality to skin said functionality. So if you're playing back music, for instance, it'll load a music XML file. it had better be there for every skin that is there. And if they add new C++ functionality, skins can actually get broken by the advancing of the C++ functionality. Whereas with our skins, the only thing you need to know about basically is the actual way in which data is actually exposed via the models. That's the only interface that you really need to worry about. So we actually have skins that use QML 3D, for instance. We have skins that actually are aimed at automotive. With skins that actually are using QML2, the individual skins themselves basically can actually set what their base requirements are. Yeah, it's very flexible in that regard. The intent of this project is to be something of a QML playground. As mentioned, we've done the heavy lifting. You should actually be able to go through with QML and actually do whatever you actually need to do, or actually rather just ignore the actual data collection and focus more on the actual representation and see what is possible. The ideal would actually be that you guys would actually sink your teeth into it, fork one of our skins to make your own. We're perpetually forking each other's skins, and actually engaging in political discussions. So like, yeah, it's very straightforward to actually get to work and start modifying things and seeing quick results. Especially if you have hardware embedded targets. We have this same thing running downstairs on the demo stand on various hardware platforms. If you work on certain devices, you could get it compiled running on different devices. We're running on Qt embedded devices. We require very little in the way of functionality. If you're using a raster frame buffer, performance is going to be terrible. We can tell you that in advance. But with just OpenGL on an embedded board, it will enable you to actually evaluate QML's performance on your hardware. The bridges that we crossed in QML, which actually turned out to be like pain points or focal points or like major achievements by our reckoning. The focus management, as mentioned before, QML has a very strong emphasis on touch-based, like a UI. So keyboard handling and actually trying to actually manage the focus chain, and we ended up using something of an imperative approach where we're using force active focus on a regular basis. It's actually initially when we first started working on it, we'd find that we were all working in parallel on different QML items, and you'd come in one day and the focus was being stolen by all of us. We were all competing for the same focus. What we actually established upon, where we'd actually have any single one item actually be assigned focus by the actual top level item, using force active focus, has actually scaled thus far. So like, that was something of a pain point, and I think you really have to go and look at the code and see exactly how we actually did it there. But force active focus is a very useful thing, and in order to actually guarantee that you're actually going to get keyboard focus, and actually have like an entirely basically predictable focus chain, it's a requirement at this point. Initially, as mentioned, we were actually loading a whole bunch of separate QML components in parallel. So when you actually first started our top level skin, every single QML component in the entire thing, all the actual video views, all the music views, everything was created in parallel. The memory consumption went through the roof. So one of the things we had to tackle as well was the lazy loading of components, where we actually use the QML create component stuff to actually do component creation at runtime. And as soon as you actually close them, as soon as you actually exit out of them, they are deleted. So, depending on the actual hardware that you're working on, of course, creating and destroying components is quite heavy, but like you're also battling memory constraints as well, and you always have to actually try this out for yourself and try to reach some kind of compromise. We have people shipping QML devices with less than 128 megs of RAM. You can't really afford to actually have any kind of multi-screen thing just kicking around. It doesn't really work very well. As mentioned, so with database integration as well, we also are able to build queries on the fly from the QML file. So one of the problems you actually have by actually having all your data in the actual, having all of your core logic in C++ is that you always have to strike a balance on actually trying to have, it feels very odd having this infinitely flexible skinning mechanism if your models are constrained to having a fixed format the whole time. So we actually enable you to build SQL queries on the fly in the skin using plain text, and then this is mystically handled in the back end by that man over there, Grish. Yeah, cool. And as mentioned, many of the devices that we're trying to ship on don't actually have Qt Multimedia Kit support. Qt Multimedia Kit has a hard dependency on X11. We're trying to actually run on a range of different embedded boards with different layers and different proprietary libraries that actually are responsible for media playback. We therefore actually had to have the actual eventual media playback abstracted back into C++ again, where we actually use either dbus or QProcess, depending on what they actually provide us with, to actually drive the actual media playback. Yeah, and then like the actual apps that are actually like present, basically, we did implement a an app launching mechanism, basically, a means by which people could consistently introduce third-party applications, so we can get partners to actually provide apps. And actually, you know, one of the things that we're not doing at the moment, which we'd like to actually do, is a sandboxing of applications, which has been dealt with recently on the actual QML mailing list, or at least raised. But yeah, we did come up with a functional way of actually having arbitrary third people providing QML, although they can still break the actual primary skin. As mentioned on these embedded devices, very often video playback occurs in a secondary plane. In that circumstance, you actually need to have shine through occurring. You actually want to have Qt just not painting or disregarding certain areas, and clipping is always a substandard solution to this problem. The idea would be to actually paint nothing at all. So we actually tend to actually just clear the entire surface using OpenGL, and then actually render into it using our declarative view, rather than using the actual GL viewport. And therefore, actually, any video playback that's occurring on a backing video plane actually shines through. So these are all things that are actually done and actually approached and tackled in the actual code itself. Normally, it's a matter of setting a certain flag, which actually happens to be non-evident to you, and rather than just put it up on screen as being like a no system background or like a transparent window flag. Again, I'm relying on you guys actually checking out the code and actually seeing what is actually there. And we got the actual, we got QML2 skins functioning on the media player. It took 2 hours and was largely a matter of actually doing a sed replace on our existing skins. Of course, it doesn't actually provide us many of the benefits of QML2, but the point was it largely worked out of the box, just doing a direct string replacement of QtQuick 1.1 with QtQuick 2.0. There was some widget stuff that we clearly had to adjust, but it was a 2-hour-long process. And at the end of it, we could actually start benchmarking the performance of Qt 5 and start trying to address bottlenecks and trying to see whether the benefits that it was promising have been fully delivered or not. So Qt 5 is still very much a work in progress, but we are heavily testing it on different embedded targets. And I can say on behalf of the actual embedded team that at least the actual prospective architecture of Qt 5 is very, very appealing. So it was very important that we start showcasing it now and start actually trying to establish where there are any pain points, should they exist. So getting down to actually like a core resolution and independence, don't mind me. There are 3 particular things about QML that are directly relevant for resolution independence. Anchor layouting is incredibly convenient, basically, and actually just laying out your components relative to others. Once you've actually used that kind of functionality, it's incredibly possible to actually go back to either fixed points or actually doing the arithmetic yourself and actually constantly laboring over that kind of thing. The time expenditure in getting something up, running, and demonstrable is uncomparable, basically. And with both anchor layouting and relative sizing, we've gone pretty far in the confidence skin to support a wide range of different resolutions. We use these 2 mechanisms. We use the anchor layouting that's provided in relative sizing. I'll discuss that more later. And then in the actual skin itself, we actually use a different skinning mechanism where we query the actual top level widget and try to find out what the dimensions are of the actual desktop. And depending on that, we actually load different QML files, which is, it's the only rational way of doing it, basically. So we actually literally have a mapping from a certain string that we actually calculate, depending on what we think the closest approximation is, to a QML file. Further considerations, especially to people who work on embedded targets where there is actually constrained hardware, are things like file I/O. On many devices we have downstairs, loading an image that is any larger than necessary can entirely bog down your board. It's as simple as actually changing between the items on the list view downstairs. Every time you change between an item, a different actual pix map is actually loaded. And with a 720p pix map, you can actually get like a complete block on your primary thread, and your GUI can actually lag for like you know, it's a palpable period, like possibly half a second. So you really don't want to be loading images that are any larger than necessary. It's another consideration. Trying to actually scale images, of course, is unnecessary overhead. So these are all things that you need to actually bear in mind. And of course, the fundamental usability of your application is going to change depending on the actual resolutions you're dealing with. But what I wanted to actually focus on there was that performance is a primary criteria as well. So with our actual primary skin, it's actually targeting 720p resolution, and it resides under a directory which actually directly reflects that. If there was a skin that targeted 800 by 480, for instance, like the N900, it would actually reside under a corresponding directory. But even within the 720p skin folder, we actually anticipate the fact that that same skin will be used for resolutions running the gamut from 1024 by 768 all the way through to 1080p. So we actually have discrete pix maps for each resolution in that range, basically. So of course, you're going to be interpolating the whole time, but I'd argue that it's better to actually interpolate, and I'd always be interpolating down from a nearest closest approximation than actually loading unnecessarily large images. Even with Intel hardware and other really popular standard hardware, file I/O can be incredibly expensive. And yeah, of course, the aspect ratio has got to be borne in mind. It's not really a matter of just resolution, but aspect ratio, because that really determines the actual layouting of your app and the way you'd actually want it to actually look and feel in someone's hand. So this one single 720p skin that we actually have enabled us to actually have a viable, decent-looking client on a WeTab, set-top boxes, a whole range of them, and desktop machines. Design considerations have to factor in input methods and the aspect ratio, as mentioned previously. It's clearly not binary. So one of the things that we want to do in Qt Media Hub is actually have just gesture-based control. Since we actually have mobile devices all around us the whole time, and everyone else is busy consolidating on actually having, a whole bunch of screens that are all aware of each other. Every device actually manages to cooperate with all the other devices, and they all interoperate. It's not as simple as actually disregarding gesture support for high-resolution displays. For instance, we're coming to the point now where we do actually require this. And for instance, keyboard support can still be useful for smaller devices. So even though it's not a binary thing where you need discrete skins for different input mechanisms and different resolutions, it should clearly actually drive the design of your actual skin. Yeah. One of the drawbacks that we hit, and this is a drawback that everyone's going to hit, and it's by no means actually solved at this point, is that of actually manually synchronizing your code when you actually have major work done on one single resolution. And in Qt Media Hub, we actually entirely changed the actual model infrastructure that was actually used behind the scenes to actually advertise data. And the delegates, which are very resolution specific, were actually tied to the model information that they have to be. And at that point, we basically had to actually scrap the original skin and actually do a rewrite for the lower resolution device. So when you actually have a complete refactoring of your code, then clearly trying to synchronize that between multiple resolutions can be very tricky. And the way to work around this, as we all know, is to actually componentize your code as much as possible to move it off into components. So things like the actual path view specializations that we actually have, the cross-resolution path, the path view specializations that we have are entirely relevant cross-resolution, whereas, as I mentioned beforehand, the delegates actually need to be very resolution specific. Cool. Yeah, I will now move on to actually discussing the actual merits of QtQuick for various devices and how it's actually not just constrained to mobile devices. QtQuick is a domain-specific language, and for some reason, we've actually always been stressing that it's incredibly designer-friendly. But one thing we have to point out that it's actually very friendly to C++ developers. And actually, first actually using it, there's of course a learning curve, and we all have to deal with that basically. And the main benefit of it is that it's not actually actively designer hostile. You can sit there with someone who has no clue about C++, and it's one less abstraction for them to worry about. They don't have to look at C++ and try to actually imagine how this is eventually going to look on screen. It's very easy to actually map it one-to-one to the actual end user content on screen. It's very human readable. Not that developers are not human, but it certainly lowers the bar significantly. So we're all pretty much sold on C++, clearly, but for UI design, it really does serve its purpose. And like going away from it or going back to it or going back to a C++-based API or something like graphics view is a very daunting prospect, actually. So the design considerations behind QML, you should all be kind of familiar with. For a cell phone, you could imagine. The iPhone came out, it was very pixmap based. It's very easy to actually accelerate pixmaps. It maps very nicely onto the most common acceleration mechanisms available today, which is namely OpenGL, which is on all your embedded devices by now. And it's making massive intrusions into set-top boxes, which extends your battery life. Yeah. It also tends to be like a large and friendly, like a finger-friendly. So our old painting, our old Arthur paint system was very good for actually drawing small primitives, basically. But when you actually try to use your big fat finger with a small button, having small little primitives or having small little components does not help you at all. Like, really, given the surface area of your finger, you will always want to be dealing with something which is basically a pixmap. And of course, compared to visual effects, in the mobile device space, what is selling devices is actually Flash. And what worries me is that, again, we overstress the actual, the flashiness of QML rather than just the convenience and the actual, production time, development time, and other aspects of it. But this maps very nicely onto large screen devices again. So again, being pixmap based, as I mentioned, the acceleration mechanisms are identical between your mobile device and the actual set-top boxes, and it maps incredibly well to OpenGL. And the exact same functionality that actually helps with your touch friendliness also helps drastically with 10-foot displays. TV displays tend not to be overly cluttered. They can't actually be filled with tiny items. You tend to have like a couple of items on screen, maybe 20 items, exactly like a phone. They really are, surprisingly, there's a lot of commonality between them. And again, the visual effects are becoming increasingly important. So the considerations that clearly come to the foreground when dealing with QML, performance is probably the most highly discussed one. If you track our mailing lists, if you actually are involved in our mailing lists, or if you are involved in the flame wars, people constantly worry about the actual overhead of JavaScript, and they're worried about memory consumption and many other valid concerns. But what they tend to always disregard is actual GPU considerations and just how incredibly computationally expensive it is to actually try to do graphical things, especially for high-resolution devices on the CPU. It really does not scale very well at all, and at some point, if you're actually trying to actually tackle higher resolutions, it really is not a linear thing at all. The raster engines do not scale very nicely. So in Qt4, if you actually use our OpenGL graphics system, beneath the resolution of 1024 by 768, depending on what you're doing, it was quite possible to actually get a performance hit by actually using our GL graphics system due to the overhead of actually setting up GL calls and actually the mapping from our graphics system onto GL in the first place. Whereas as soon as you start heading into higher resolutions and more pixmap-friendly coding, the gains were far more evident. It was a far more evident thing. Another consideration when we're dealing with QML is actually the jump stop penalty that exists in C++, where you've got to actually code up the actual core logic before you can start working on the actual UI itself. So, for instance, as you all know, there is a QML viewer application that enables you to immediately start viewing your QML. So the time to actually get a pixmap on screen and to start working on different actual items that fit within that. I can wave my hands right now, but the Xbox Media Center skin is something that I guess really needs to be demonstrated in order for this to be. And I've never actually tried running this presentation, Qt5 presentation, in conjunction with my Qt4 Qt Media Hub, but I'm sure everything will go swimmingly. Cool. So the discrete components that you actually will see on screen over here, you actually have a single blade, is what the Xbox Media Center guys call it, on your left-hand side, which is, it's not actually anchored against the left-hand side of the screen because it has to actually slide in and slide out. So using anchors there would be suboptimal, just actually changing the position. But each of these main top-level items corresponds to a corresponding a QML file. It actually maps incredibly gloriously onto the language. So whereas the Xbox Media Center guys, as I mentioned, have to use this XML format that actually specifies where individual components are laid out, I could basically immediately start actually hacking on individual guys, targeting it, and getting something that was very recognizably Xbox Media Center. So if not designers, because there were no designers involved, other than the guys who contributed these pixel maps very, very generously, management and people further up the actual dev chain could actually immediately see results and actually see things like the actual transformations that were very easy to mimic using QML. It's just a matter of changing certain properties. It was remarkably easy to actually get something demonstrable and actually vaguely approaching the actual Xbox Media Center skin incredibly rapidly. Cool. The long and short of it is basically, there seems to be a very strong message or trend on the actual mailing list that we actually have moved away from the widget system and are moving towards QML due to some kind of political force, whereas what people need to actually realize is that we did try to optimize the existing Arthur Paint system as much as humanly possible, and a large number of very bright people spent a large amount of time basically doing shaving level optimization, where they're trying to actually shave things down and get minor actual gains. But pushing pixels is fundamentally bad, and pushing pix maps is good. You upload things to your GPU, you upload them once, and then you manipulate them there. And trying to actually compete against that by pushing pixels is just the wrong way to do it. And no one else is doing it. We would be non-competitive if we were to try to take that route. So although there are things like OpenVG that might actually make pushing pixels somewhat more performant, as a guy who touches a lot of embedded hardware the whole time, I've basically dealt with almost no boards with OpenVG support built in, and the ones that do very often do it by mapping onto OpenGL in the back end. So the number of boards with discrete OpenVG silicon is vanishingly small. We did actually try to actually do something similar to the actual Xbox Media Center skin the previous year using graphics view. As I mentioned, we wrote a war with a C++ thingy, where the definition of thingy is an ill-defined demo that was meant to be demonstrating the raw blissing performance of graphics view coupled with our GL Paint system on various devices. As I mentioned earlier on, I got to learn firsthand about how at some point, as you actually scale down in resolution, you start getting negative gains from our geographic system. What you'd actually see is a demonstrable drop in CPU usage of the actual Qt application. When you start, you'd see a demonstrable drop in the actual X11 CPU usage of your application and a demonstrable increase in the actual Qt usage of your application as it had to tessellate an increasingly large amount of information. It was a very useful demo, but having gone through that and then actually gone through the subsequent a QML-based application, it was a very pleasant experience comparatively. It ended up being the road to hell, and we actually had to fight graphics view every single step of the way. Most of our code was working around inherent graphics view behavior. Our code did not emerge into the light of day. We tried to actually get it out, but legal barred us, which was pretty good, since light is the best disinfectant, it probably wouldn't have survived for very long. There isn't really much of a comparison between QtQuick and QGraphics View, but people seem to keep on insisting that we try to match the functionality or the performance that was actually issued by the chips demo, which I used to be a very big fan of. As I mentioned beforehand, QtQuick is a domain-specific language, right? And if QGraphics View is specialized in any kind of way, it's specialized for the chips demo itself. So that isn't exactly a fair comparison. But as you know, in the round one of actually the QGraphics View, we actually tried to actually the Qt declarative view is a subclass of QGraphics View, and hence people are complaining about using yet another abstraction, which they see as being a performance gain, a performance hog. but basically someone's abstraction will probably end up eating your performance. As I mentioned beforehand, like Xbox Media Center have this XML skinning engine. I mean, you basically cannot actually sit there and readily actually do something that actually approximates the Xbox Media Center look and feel without some kind of abstraction layer between the graphics view and you. And if you were to try to actually do it yourself, you'd probably end up re-implementing something that was awfully similar to QML. We've had many customers who actually started projects just before QML who've ended up with very similar final abstractions. A better question is how many abstractions are actually eating my performance, which is exactly what leads us onto QtQuick versus QGraphics View round 2 in Q5, where we've just entirely bypassed QGraphics View. And anyone who actually objected to the original additional overhead of a QDeclarative view over QGraphics View now won't actually benefit from the simple fact that we've entirely removed that entire stack, and now it maps directly onto OpenGL. Yeah, it's just trying to take my time. Yeah, so as I mentioned beforehand, it took roughly 2 hours to actually get the actual the Qt Media Hub demo actually running to some extent on Qt5 as it stands right now. The Lighthouse backends, it has to be mentioned, or the QPA backends, are fairly immature, so we couldn't actually get it to be a one-to-one mapping and functionality, but you get stuff on screen demonstrable and usable as it is right now. So yeah, that would have been a direct benefit, and anyone who has done QML-based development right now will be able to start building Qt Declarative right now, or rather Qt5, the Qt base module and the Qt Declarative module, and start testing themselves against Qt5 as it stands right now. Cool. Anyone who's actually intrigued by the possibilities of QML, the performance possibilities, should really look at the Raspberry Pi demo downstairs. It's a Broadcom ARM11 CPU. It runs at 800 Bogo MIPS. It's a really old, really low-powered CPU, and it's actually got the Broadcom Media Core 4 GPU, which isn't going to mean much to most of you, but it's capable of actually driving a 1080p screen and actually showing some pretty impressive shader effects. So I'd really advocate going downstairs and actually looking at that if you haven't already come past and actually seen it. There are videos available online as well. Questions? Please, yeah.
I'd like to ask if you are aware about the configuration issues when you want to use OpenGL ES. Because I think the standard Qt SDK comes configured for the OpenGL, and reconfiguring it for OpenGL ES takes already some effort. Then you have to have your environment configured with the right EGL environment, Mesa drivers, things like this. And the third thing is, I guess, the drivers for the GPU that you have. And all this process takes a lot of effort to set up on your system, which is totally unconnected with the development effort. And I think if you could have some improvements in this area, it would be a much of an advantage.
Cool. Which targets in particular are you referring to?
I've been working with Intel target. It was Intel Atom and Intel's EMGD.
Okay. Yeah. I've never actually tried to use QCreator in conjunction or with embedded hardware like that. So yeah, it's one of those things I can take back or can investigate, basically, the integration. But are you talking about trying to actually build Qt itself, or actually just trying to build Qt examples and actually trying to actually target OpenGL ES2 based applications from within QCreator?
Well, I've done some performance analysis in terms of comparison the OpenGL with OpenGL ES. On that target, it was MIGO with Intel Atom Pro CPU and Intel EMGD. And going from OpenGL to OpenGL ES gives about 70% better performance. And just forcing the system to the whole configuration to use the OpenGL ES takes a lot of effort.
Okay, cool. I think there's something which I need to do here, and so I know that Intel do have a Qt creator, and they do actually have an SDK. I'm not really familiar with what they've actually provided, and how this is actually managed, but I will actually investigate it. Actually, this is the only thing at the moment, because I don't know whether this is a shortcoming in Creator itself or in the way it's actually delivered. Have you used it? Do you? Okay, no, I thought you were nodding.
No, there won't be any integration for Creator. I think so, because at the end you need to build Qt on your own using the proper make specs.
But yeah. I mean, like it's certainly it's no major task or no major problem to actually get Qt built and running on any device of your choosing. But Johannes, I think that there is an Intel SDK that's provided that actually has these hot targets there basically. And if that is the case, I just need to basically look at what's provided. But there's something of a disconnect between Intel and ourselves, and I basically have no familiarity. There isn't a single device that we offer that has both OpenGL and OpenGL-ES as two separate configurations on the same device. So this entire configuration step, I think, is not something that has been tested or been pushed by us at all. But it should definitely be possible. I agree with you. But I would need to look at it.
Yes, and the other thing, I would like to know how far ahead are you with going versus going to facilitate the QML access for the designers? Because I've heard that there is a Adobe Photoshop plugin that will export to QML or QtQuick.
Yep.
And I would like to know how intensive is the work in that direction.
Cool. Okay. Do either of you guys know? Do you know it all? Again, there is a guy here called Jens, who's definitely the man to actually speak to. The guy who was responsible for the actual Photoshop plugin that you're referring to is actually at this dev conference, and he'll be able to give you a much more accurate idea.
So, I think we have such a thing, but it's not very stable, and at the end, it's easier to write the QML from scratch and just get the proper PNGs from the designers. So we won't have a rewrite of Photoshop, something like that. So we just say, okay, use those tools because the designer wants to, and tell them, give us good, nice PNGs that will fit. That's, I would think, the best thing.
But as mentioned, the author of the plugin you're referring to is actually here. So if you track him down, I don't know Jens' surname, but I can describe him to you in front of an audience. If you come to me afterwards, I'll try to actually lead you to him. Yeah, cool. Anyone? No takers? Cool. Yeah. Thank you.